Assalamu alaikum. Hello everyone, I am Ala Talash, a PhD student at University Malaysia Bahang. I am here today to present our research work under the title Properties of Sustainable Concrete containing recycled fine aggregate as a partial sand replacement. Presentation outline. We will start with the introduction and after that the problem statement of our study, objectives, materials and method, mixed proportion and testing, result and discussion, and at the end, conclusion. Introduction. Every year, more than 30,000 million tons of concrete are produced worldwide. The rising of concrete manufacturing also derives for larger consumption of its raw material, such as both coarse and fine aggregate harvested from the environment. In view of preserving the natural environment, alternative material derived from the disposed waste from industrial or agricultural activity would be able to reduce the dependency on the sand supply. Problem statement number 1, fine aggregate issue. Every year, over 50 billion tons of sand and gravel are mined across the world. Sand mining can impact environment in a few ways, such as destroy water quality, destroy the aquatic life, and change in the river bed. As shown in the figure, this figure shows some of these environmental impact of sand mining. Problem statement number 2, construction waste. 30 to 40% of total solid waste generated currently consists of construction waste. Construction waste can impact the environment in a few ways, such as contamination of soil and water, loss of land for landfill, and damage to landscape. Also here some of pictures shows the environmental impact of construction waste. Objective of study. The first objectives to investigate the effects of recycled fine aggregate as a sand replacement in workability of the concrete. The second objectives to investigate the effects of recycled fine aggregate as a sand replacement in the compressive strength of concrete. The third objectives to investigate the effects of recycled fine aggregate as a sand replacement on the water absorption of concrete. Materials and method. Concrete samples were collected and broken into smaller pieces and then sieved using sieving machine. Only aggregate passing 5 mm sieve and returned at 150 micrometer sieve were collected to be used as a recycled fine aggregate. Recycled fine aggregate was washed using tap water to remove dirt and dried by placing it in oven at 105 Celsius for 24 hours before it be ready for use. Mixed proportion of concrete mixes. In this table shows the mixed proportion that used in this study. The recycled fine aggregate was used in varying percentage to replace the sand. This percentage is 10%, 20%, 30%, and 40%. Testing. First test, the workability. It's conducted according to the British standard number 12352. Compressive strength. It was conducted according to British standard number 12393. Water absorption is conducted according to British standard 1881-122. Now the result and the discussion. In the first, we start with the workability. As shown in the figures, the concrete slump becomes higher as more recycled fine aggregate is integrated in the mixture. Therefore, the control concrete exhibits the lowest slump or workability value, while concrete with 40% recycled fine aggregate demonstrates the highest slump value that is 155 mm. This may be attributed to the use of larger sized of recycled fine aggregate, which possesses lower surface area as compared to finer sized sand, has resulted in an increment of workability. The second is the compressive strength. As shown in the figures, the strength becomes lower as more recycled fine aggregate is integrated in the mixture. Therefore, the control concrete exhibits the highest compressive strength value. This could be attributed to the use of coarser recycled fine aggregate with a smaller surface area than sand has resulted in existence of extra mixing water which causes formation of void in concrete. However, concrete with a 20% recycled fine aggregate achieves the target strength value, which is 40 megapascal. At the end, the water absorption. As shown in the figure, the addition of recycled fine aggregate to concrete increases the water absorption of concrete. The water absorption for concrete with 0%, 10%, 20%, 30%, and 40% recycled fine aggregate is 1.49, 1.92, 2.41, 2.56, 2.76% respectively. However, all concrete samples had a water absorption less than 3%, which indicates it's a good quality concrete. At the end, the conclusion. These conclusions are withdrawn from our study. The use of recycled fine aggregate as a sand replacement enhances the workability of the concrete. The use of 20% of recycled fine aggregate as a partial sand replacement produces concrete with targeted strength. All specimens containing recycled fine aggregate up to 30% exhibit water absorption less than 3%, which indicates it's a good quality. The production of recycled fine aggregate from concrete waste assists to reduce the dependency on the natural sand supply and the preservation of river environment. In the last slide, here we show the reference that used in our study. Thank you everyone for the attention.